salts. So we have studied about the acid, we have studied about the bases. Now the last topic are the salts. Now we know very well whenever the acid reacts with the bases, what do they do? They form the salt. So this itself is a first point. Just one. So this itself is the first point, that salts are formed when acids react with bases. We know very well when acid reacts with bases, the salts will be formed. So what happens? The name of a salt, you know very well, if we talk about any salt, that name of the salt will consist of two parts, right? Have you ever noticed that whatever salt we talk about, it has two parts, two names in it? Yes or no?
Yes, ma'am.
Like sodium chloride. How many parts do you have in sodium chloride? Only one or two?
Two.
Two, correct. So it has two parts. Out of these two parts, the first part of the name is derived from the name of the base. So sorry. So always keep in mind, the first part of the name of the salt will be derived from the name of the base. So whatever the base was reacting in the reaction, so that will be the name of it. Now coming to the second part, the second part of the salt will be deriving from the name of the acid. So always the first part will be the base and the second part will be the acid. Now let us see the examples for it. First, very easy example is sodium chloride. Now sodium chloride, this sodium is what? Acid or base? So those both together, they are what? They are the salt both together. This sodium is what? The base, and this chloride is what? It has been derived from the acid. So that is why we always say that it has two parts. There are two parts for the salt name. The first one is from the base and the second one is from the acid. The first one comes from a base called as the sodium hydroxide, which is, what is the formula of sodium hydroxide? NaOH. And the second one, the chloride, the word comes from the hydrochloric acid. So when sodium hydroxide and hydrochloric acid reacts with each other, they form the salt. Chloric acid, they form the salt called as the sodium chloride. So this NaOH, the reaction will be NaOH plus HCl gives what? It gives sodium chloride, NaCl. So this Na will join with the Cl and the water will be released. Same way now, if I talk about the magnesium chloride, this magnesium will be coming from which base? What will be the hydroxide? Very good. So it comes from the base called as the magnesium hydroxide, and the chloride comes from the acid called as hydrochloric acid. So that is the reason what happened. This base, first name, we take this as a magnesium, and the second one, chloride, is the acid part of it. Now the next topic are the types of salts. So as we have discussed the types of acids, types of bases, same way we have the type of salts also. The first type is acidic salts. So acidic salts, are those salts which are formed when what kind of acid will react, strong or the weak? In the acidic salt, what will be reacting? The strong acid or the weak acid will be reacting?
Strong acid.
Correct. So when the strong acids reacts with what kind of base they will react with? Weak bases. So when the strong acid react with the weak bases, they form the acidic salt. And always keep in mind that the acidic salts, they will have the pH of less than 7. Always they have the pH of less than 7 and they are called as the acidic salt. Examples of it, like ammonium chloride. The first example is ammonium chloride. What is the formula for ammonium?
NH4.
Correct. NH4. And chloride, how do we write?
Cl2.
Cl. Chlorine, that is Cl2 is chlorine. Chloride is Cl. All right.
Okay.
So ammonium chloride. Then we have the aluminum chloride. But here now what happens? Always this chloride will not be always Cl. It depends upon the first part of it. Aluminium, when we write about the aluminium, the formula of aluminium is Al. Fine. That aluminium is Al and then chloride here will be Cl3. The reason why this 3 has come because the aluminium has 3 valency. So valency basically they are the number of electrons which are present with them. Now what they cannot keep it with themselves. What do? They give it to the chloride and that is how they turn into the Cl3. So in the upcoming chapters and all, we'll be discussing about this, but here you should know what is AlCl3. So aluminum chloride it is, but chloride has 3 numbers. Why? It is because of the aluminum, because it has 3 valency with it. So these are what the acidic salts. Now in the next one, we have the basic salts. For the basic salts, what will be reacting? The strong base will be reacting or the weak base will be reacting?
Strong base.
Correct. So those salts which are formed when strong base, always in this, the strong base reacts with the weak acid. So always in this, the strong base will be reacting with the weak acid and they will have the pH value of more than 7. So more than 7, they have the pH value of it. Coming to the example of it, the example is sodium carbonate. Sodium carbonate. Now here again, the formula is Na. Usually we write it as sodium as a Na. But what happens in this case, since carbonate has also some valency with it, so that is the reason it will be changed into Na2CO3. Because of the valency, the number of the Na will be changed to 2 and the carbonate will be CO3. So when you balance all these reactions and all, then you will be getting this formula. So that is what the sodium carbonate. Another example is sodium acetate. Sodium acetate. So basically sodium is Na, acetate is CH3COO. But in this case, what happened? we cannot write BO at the last. So what we do, we change it to the CH3COONA. Because why we change this? Because we have said already that whatever salts are there, always the first part will be the base in it. So according to the base, this rule is correct. This answer is correct, NaCH3COO. But O cannot be present at the last because the bond will not be completed. Do you know what are the bond? BOND. Have you ever heard this word bond?
No, ma'am.
Kritvik?
No.
No, none of you have heard this word bond? Okay, I'll tell you. Basically, if I talk about the bond, you might have, like, generally you might have used it for yourself. Like, my bond is stronger with my mother, or my bond is stronger with my father, or my bond is weaker with my sister. So usually you have used this word, right? The bond, basically the connection with any kind of the relatives or your family member, whether it can be strong, whether it can be weak. Yashwant, turn on your video. In the chemistry also, you have the same thing. Here the meaning of the bond is how much the frequency is there to hold the element, how the tightly elements can join together. So depending on the bond, depending on their strength, how much holding power they have, they are divided into 3 bonds. I'll write on the screen. So depending on the strength of it, they are divided into 3. So bond here means the strength for joining between the 2 elements. So single bond we have, then we have double bond, and the last we have the triple bond. Single bond, double bond, triple bond. Now you tell me, out of, so single bond will be always like this, double will be like this, 2 lines will be there, and triple will be like this. Now you tell me, out of these 3 bonds, which will be the strongest one?
Mom, triple bond.
Correct. The triple bond will be the strongest bond. The reason why the triple bond is called as the strongest bond, because it will take time to lose the connection, or we have to heat it very much to break that connection or to break that strength. That is the reason it is considered as the strongest bond. And single bond is like the weakest bond because it can break automatically also. Clear? So in the case, if now we talk about the sodium acetate, why we are writing it as CH3COONA? We are writing like this, not like this. The reason why we are writing like this one, the upper one, it is because if we write in this down form, then what happened? This O can easily break down. The bond which is present with the O can break down easily. That's the reason we turn it, and when we write it, first we write the acid there, CH3COO, and then we write the base there, Na. Understood, children, why we are doing so?
Yes, ma'am.
Yes.
Okay.
Ma'am, I have a doubt.
Yeah.
Ma'am, is the acetate, is there acetic acid?
No. Acetic acid is basically CH3COOH. This is common. This is acetate only. But in the acetic acid, the H will be there in place of Na.
Okay.
Fine. The upper one is acetic acid. Okay. Now coming to the last salt, that is the neutral salts. So talking about the neutral salt and them, what happens? The strong acid will be reacting with strong base. So to neutralize it, both the things should be the strong or it can be the weak. So depending on that, it is like the neutral salt. And that is the reason they have the pH value of 7. And the water we drink, it has what is the pH for water which we drink?
7.
Good, Kritvik. So that's the reason we are able to drink it, because it is neutral in nature. So the water has the pH of 7. It has neutral condition, and that's why we are able to drink it. Now imagine if it has less than 7, we would have not drank it. If it is more than 7, then also we cannot drink it. So since it is 7 with the pH of 7 value, that's the reason we are able to drink it. Now example of the neutral salt is NaCl. What is the name of the NaCl?
Sodium chloride.
Sodium chloride. So NaCl is sodium chloride. Then the second one is the KNO3, which stands for potassium
hydroxide.
Nitrate.
nitrate. Hydroxide is KOH. This potassium, NO3 is nitrate. So potassium nitrate. Now coming to the properties of salts. So the first thing, they act as a good conductor. The first thing, act as good conductor of electricity. So they will be acting as a good conductor of electricity, and that's the reason we will be able to produce the electricity with the help of this. The second property of it, that they are soluble in water. So whatever the salts are there, we can mix them in the water. Like the normal salt also, you can mix them into water. They are soluble in water. Now third very important property this is, so generally the salts are white crystal, like the normal salt we have, the Tata salt or maybe the rock salt, they are white in color or the shade of white crystal they are. But some are colored also. Some are what? They are colored. So some are white and some they are colored. So example of the colored is CuSO4. What is CuSO4? What is Cu?
Ma'am,
Calcium
cupric sulfide.
No. It is coppers. Cu stands for copper and SO4 is sulfate. So copper sulfate is generally blue in color. They have the blue crystals actually. Fine. So some salts are white in color and some are colored. So colored salt like the copper sulfate, which is blue in color. So that's about the properties of the salt. And the last topic of the chapter are the uses of salts, where we can use it. Now you know very well NaCl, sodium chloride. It can be used for seasoning, for making the gravy, for preserving the food. So preserving food, seasoning, and it is important for the functioning of the body also. So in our body also, the salt is needed. So functioning of the life processes also, it is important. Now the second one, we have sodium bicarbonate. So Na stands for sodium, H stands for bi, and CO3 stands for the carbonate. So sodium bicarbonate. Do you know what is the other name of sodium bicarbonate? Baking soda. I think at your home, mothers might be using this baking soda. Are they using it?
Yes, ma'am.
Yes, ma'am.
Right? So where they are using it? What they're making out of it?
Ma'am, cakes.
Correct. For making the cake, for making actually for, or in a simple language, we can say for baking. So if they want to bake something, they will be using the sodium bicarbonate, as well as they are used in the fire extinguisher. Fine, they are used in the fire extinguisher. Now the third one is sodium carbonate. The sodium carbonate is Na2CO3, which is also called as washing soda. So everybody at home are using the detergent, right? For washing the clothes, we are using the detergent, and that detergent is called as sodium carbonate. So this sodium carbonate is used as the detergent to wash the clothes. Then the next one is calcium sulfate. Calcium sulfate is CaSO4, which is also known as plaster of Paris. So calcium sulfate is known as the plaster of Paris. So it is used in the cement industries. You might have seen, like on the roof of the houses, we have some designs, right? Some designs are being made by the people. So those designs are made out of the plaster of Paris, which is calcium sulfate. Clear?
Yes.
Then apart from this industry, the fifth one, calcium carbonate. So this calcium carbonate is CaCO3. Limestone. It is called as limestone. You might have seen that before, like if you want to do the wall paintings and all, if you want to paint your house, what the people they will be doing, the painters will be first putting the white color paint on it, right? White color paint like thing on it. That is basically the limestone. So it is used in construction of building. So that base they will be using first for doing the paint. So that is what the limestone is. Then the next one, ammonium chloride. Ammonium chloride is NH4Cl. And this will be used in the dry cell. What is dry cell?
Battery.
Correct. Correct. So the battery, normal battery is the normal cell which we use for the toys or in the AC remotes and all, they are called as dry cell. So inside those dry cells, what will be there? The ammonium chloride will be there. Fine. That's about the whole chapter related to the acid, bases and salt. We'll just go back with the salts. We'll revise it once. Okay. So the salts, they will be formed when acids are reacted with the bases. It consists of two parts. The first part will always be the base and the second part will always be the acid. Example, sodium chloride. The sodium is the base and chloride comes from the acid, which is hydrochloric acid. Then magnesium chloride. Magnesium is the base and chloride is the acid. Three types of salts are there: acidic, basic and the neutral. In the acidic, the strong acid will be reacting with the weak base. Example, ammonium chloride and the aluminum chloride. Then basic salt. In this, the strong base will be reacting with the weak acid. Example, sodium carbonate and sodium acetate. Then the third type of salt is called as neutral salt, where strong acid reacts with a strong base. Example, NaCl, potassium nitrate. Then properties of salt, they act as a good conductor of electricity. They are soluble in water. Some are white crystal in color and some are blue in color, some are green in color. They are colored. Uses of salt, NaCl will be using for preserving, for life process, for seasoning. Sodium bicarbonate will be using as a baking part. Sodium carbonate will be used as detergent. Calcium sulfate will be used in the cement industry. Calcium carbonate, which is limestone, will be using for construction of building. And the last one, ammonium chloride, will be used in the dry cell. Clear, children?
Yes.
Anything you want to ask from the whole chapter? Basically, the things are given very less in your book, but we have studied more because it should not be only the book we should study. I feel like we should study a little extra so that whenever, wherever any you go in your higher classes, at least you have a good knowledge of it. All right. So that's the reason we are going very deep into the things. Right, children?